All right. So before we get started on the last segment of this chapter, which is section 9, um, I want to do sort of a theoretical introduction to what we'll be doing when we get to the actual problems, because it's important for you to have a little bit more foundation on this particular topic, because this idea that we'll be doing is going to come up again and again and again all the time for you in different places. And sort of the umbrella topic, if we could put it that way, is the idea of an average. So let's suppose you can see on your screen there, I've got some numbers for you: 80, 90, 85, 100. Let's suppose that those are grades on different assignments. And on the first assignment, you got an 80, but it was worth 150 points. On the second assignment, you got a 90, but it was worth 200. Then 85, but it was worth 175, 150. Anyway, you get the idea there. So if we ask the question, what's your average grade? Well, what you could do is you could sort of naively approach this thing and go, oh, well, I'm just going to add these things up: 80 plus 90 plus 85 plus 100, and that's going to give me a number. But that would be wrong, because take a look at this. This, your highest score here, the 100, goes with the assignment that was worth the fewest points. Okay. And the assignment worth the most points, you did pretty good on. All right. So if we're gonna get a proper average, what that means is we want the average to meaningfully represent the numbers. And so what we do is we use a weighting function. Okay, that's what it's called: a weighting function, or a density function, or a probability density. There might be different names for it, but our weighting function in this case is the number of points. Okay, so if we're going to properly get an average for these numbers, what we're going to have to do is something like this. We're going to have to take 80 times 150 points. We're going to add that to 90 times 200 points. We're going to keep going there. So we get all of those grades multiplied by their weight. Okay. And then what we would do is we would divide by all of the weights. So 150 plus 200 plus 175 plus 50. Okay. Now, if you execute this, if you get a number for this, what you're going to get is you're going to get that your average grade, so I might call it G sub average, or we might call it something like this. Okay, in other situations, we might call it G with a squiggly thing on top. There's different ways we might write it down. But as long as we know that we're talking about the average, that it doesn't really matter how we indicate it. We just want to make sure that we're consistent. But that number is going to be 86.74. Okay. Now that is the proper weighted arithmetic average of your grades. Okay. So, for example, your GPA would be calculated in a similar fashion. All right. So maybe you got a B in a 4-credit course, and you got an A in a 3-credit, and an A in a 4-credit, and a B and a 3-credit. Okay. It would work the same thing. You'd have 3 times 4 plus 4 times 3, et cetera, et cetera. And that's how your GPA is calculated. So your GPA is a weighted average. Okay. So let me get rid of all this green stuff here. Oops. Boom. There we go. Okay. Now, all of you have had Calc 2. So what I want to do is I want to say, in terms of something like an equation, what have we done here? Okay, so what we did is we added up over in the GPA, or the grade times the number of points, and then we divided by adding up just the number of points. Okay, so that's, and I know it's a little goofy. That's a summation symbol. I'm doing the best I can. Maybe if I make it bigger, but then it's going to be weird. Put little things on it like this. The capital sigma is not a lot of fun to try and write a bunch of times. Okay, and so that turns out to be how I'm going to get my average value. Okay, just like that. Now, another way to think about it is, instead of calling it an average, we could call it an expectation value. All right, so that's a little fancier term, but it means the same sort of thing. All right, so I as a teacher, if I was going to give a fifth assignment, and I wanted to say, well, let's look at Michelle's scores here. She got an 80 on this 150 assignment. She got a 90 on this 200 assignment, blah, blah, blah. I'd say, well, odds are I expect that whatever I give is going to be something around 86. Okay, or 87. So I'm going to expect that she's going to get a moderately high B on whatever assignment that I give her. Okay, so my average leads to my expectation. So an average value, expectation values, those are often terms that can be used interchangeably. Okay, all right, now let's suppose, instead of having discrete numbers like we have here, and no, I still haven't subscribed. All right. Instead of having discrete numbers, what if we had something continuous, like a continuous function, for example? All right. So let me make a function here real quick. Here we go. And we'll have something on there like that. Okay. And I might say, well, along some certain interval, say between here and here, okay, if we want to know an expectation value for X, that's kind of like saying, what's my average X value? Okay, so what's my average X value? And it's kind of like a weighted thing, in the sense that in this region here, those X values are stronger. And in this region over here, those X values are going to be weaker. All right. So here I've got my probability density function, or my weighting function. I might call that W, something like that. I could call it different sorts of things. Okay. Now, what we're going to do in order to get my average value for X along this interval is I'm going to take, I'm going to do something like this. Okay. So we had the thing we're interested in and the weighting function. And we added up the product of the thing we're interested in and the weighting function. But it's not discrete, it's a function. So it's continuous. And that means we have to add up a bunch of little tiny pieces, okay? And that's where our derivatives, sorry, our integrals are going to come in handy for us, okay? So what we'll do is we're going to take the thing we're interested in and multiply it times the weighting function. Okay, so that's exactly what we've done over here. Okay, so the thing we're interested and the weighting function, we're just going to integrate them this time. Okay, and then we will divide that by the stuff we had on the bottom, which is just adding up the weighting function. Okay, So in terms of an integral, I'm just going to have w dx, just like that. And that is going to give me my expectation value for x, or my average value for x. Okay? Sort of like that. All righty. Let me get my arrow out of the way there. Okay. But we've done the same sort of thing. Okay, now let me throw another term at you. All right. The thing that we did here in the denominator on this side and on this side, okay, is often called normalization. Often called normalization. Now, when we get to an application in the next video, we'll jump right in, and I'll show you, and hopefully some of this is going to have a little bit more meaning. Okay, but normalization is when we divide by the total. Okay, and that's necessary for lots of different things. Okay, and that's going to come up in a lot of ways. So weighted averages, so we can do them as discrete things like G and P, or we can do it as with a function. Okay, in either case, we're taking the thing of interest times a density function, or times a probability function, or whatever, and then we divide it by the total. Okay, now just one other thing. When it comes to our function, where we've got a smooth probability density, or a smooth weighting function. Okay, what is this thing on the bottom here? Oh, hash mark it to death. Did you figure it out? I'll give you a clue. Starts with an A, ends with an A. Okay, that's the area under the curve. Okay, so when we normalize in order to get our expectation values, we're really looking at the area under the curve. Okay. Now I want to point that out specifically, because what we're going to do is I'm going to show you in the next video. I'm going to show you a sledgehammer. Okay, something that will work with every single problem every single time. Okay. Then once we do that, what I'm going to do for you is I'm going to show you some shortcuts. Okay. And the shortcuts depend on understanding that when we do integrate something, that really is an area. Okay. So always keep that in mind. Okay. So in the next video, we'll hit one of these things in the sense of trying to solve a statics problem. And I'll show you how all this comes together to be very helpful and just a little bit cool.